Hello, everybody. Good afternoon. On behalf of the Mexican Society for Artificial Intelligence, I'm pleased to present the following tutorial. The tutorial is Machine Learning for Financial Applications, and the speaker is Dr. León Palafox from Banorte, Mexico. Let me introduce to Dr. León Bio. Dr. León studied his bachelor's degree in electrical electronic engineering at UNAM, Mexico, obtaining the Gabino Barrera Medal. Later, he studied his master's and PhD in machine learning at the University of Tokyo in Japan. He has held two postdoctoral positions in machine learning applied to neuroscience and planetary science at the University of California, Los Angeles, UCLA, and at the University of Arizona. He worked as a data science manager at Rich IT Corporation, as a consultant for companies from different areas such as retail, finance, and tourism. He was director of the Data Science Center at Universidad Panamericana, coordinating academic programs and consulting from companies in the financial and real estate sectors. Currently, Dr. León is Director of Machine Learning at Banorte, where he leads the strategies to apply machine learning. León Palafox, Dr. León Palafox, please, now you can start. Welcome.
Hello. Okay. Turn this on. Hello, good afternoon, everyone. Thank you very much for the introduction, Oscar. So I am, first of all, thank you to SMIA for the invitation to present this tutorial. I really always like to be part of these events here in Mexico, be part of the Society in Artificial Intelligence. I always like to talk with my peers and see what's going on in the country in terms of artificial intelligence. And well, first, like before I start, just like to talk a little bit about the spirit of this tutorial. So the idea was to bring a little bit of real world application to the academic conference and to show you how very simple algorithms, like very simple machine learning algorithms, like we're not actually going to see like any very, very complex algorithms, are being used and will be used to get value from data, to make actual decisions, to do like what they call the database decision making. So you will see that even though in this conference we see like a ton of different tools and a ton of different ways to use artificial intelligence, most of the world actually are using very, very simple techniques and like things that you see in, like from Google and DeepMind and all these sorts of companies. While they're amazing and they're like state of the art, it's still like a lot of it is not being used in big companies and in like a lot of different settings. So first, I would also like to tell you that the way I give my talks is pretty much the same way I teach. So if you have any questions like along the presentation, I'll be glad to answer them. We have plenty of times like for questions and discussion and whatever like you might want to know a little bit more. So like if at any point during the presentations you want to stop me and like you want to go further into the topics, that's fine by me. Probably there'll be a couple of like stops, like interludes, like halfway through the talk. Like 3 hours is like it's way too long, and we're deep into the afternoon, so a lot of you probably are already very, very tired of being in front of a screen, like will be in the pandemic and all. So once again, thank you all of you. Thank you for coming. And without further ado, let me just, I'll share my screen. and we can start. Mm-hmm. I hope there we are. Okay. Here we are. Okay, so first of all, like Oscar already did an amazing job giving like my brief bio of me. So like currently I'm working at Banorte, like it's the second largest bank here in Mexico. Is one like we've been regarded as one of the Mexican banks that have implemented the best and analytics and machine learning strategy. So basically, I will be talking a little bit about what we do, a little bit about how you can apply different machine learning techniques to this kind of data. Which kind of data do you have when you're working in finance? Usually when we talk about finance, like people always understand like the stock market, and it's always like, let's predict like how the stock market is going to go up, how to allocate our portfolios in order to make the best decisions that have the highest possible return. We won't be talking about the stock market. Like I actually have a little bit of experience with the stock market, but I actually would like to focus on things that are seldom talked about when talking about machine learning in finance. So like we actually gonna see like some other topics, like interesting topics within retail banking. And so basically we're not gonna talk about the stock market. So just you know, like if you were hoping to hear about like how to make yourself a billionaire, like right now with machine learning, this won't be the subject of this talk. We can talk about it later, and we all can become millionaires, but not today. So Arvind Sakran, like he's a public speaker, and one of the things that he talks about in whenever like he's giving presentations is that we're witnessing the creative destruction of financial services, and everything, not only financial services, pretty much every service, it's rearranging itself around the consumer. Like actually the banks are no longer what they used to be. Like banks actually used to be like the places where you put your money, either like for safekeeping or for investing or to make money out of your own money. Like the services that a bank provided were like very concise. They're like a bank really wasn't like, really didn't have that much leeway to go one way or the other. But nowadays, actually, banks are moving to a different direction. So a lot of banks, most of the banks, if not all of them, are actually looking forward using techniques from machine learning, from artificial intelligence, to actually give a better service to the consumers, to give a better service to their clients. And people were asked like, yeah, but it's a bank. Like the banks are some of the oldest financial institutions on earth. Like one of the first institutions of earth were banks. And people would ask like, okay, so what are you, like, which kind of data do you have? What are you gonna do with all this data that you have about people? And to start our presentation, like to give us like some motivation, I want you to think, like if you have a credit card, I want you to think, like don't tell me, just think about it, about the last 3 transactions that you made with your credit card, whichever they were, in the middle of the pandemic. Like maybe you order in Uber Eats, like maybe you went and bought something in the store, maybe you bought a movie over Netflix, I don't know. Just I'm gonna give you like a couple of minutes. You can think of the last 3 card transactions that you made. Like just think about them. The last time you took out your card, you either put them in the computer and like you put them in some web page, or you went to a store and you paid with your card. It can be whatever store. It can be like a supermarket. It can be a convenience store. It can be like whatever. So just like think very deeply on those 3 last transactions that you made. Okay. Let me take a sip of my coffee. Ready? Those last 3 card transactions, the latest transactions that you made. And I don't want you to think about like all the transactions that you ever made, like just the last 3. Ready? So maybe one of those transactions was a coffee. Like maybe you went to a coffee shop, like either like you went to the actual coffee shop or you went through a drive-through, but like it was a cup of coffee. And you went, you pay, and seamlessly like you took out your card, you paid with your credit card, and that was like the whole transaction. How many times a week, a month, or a year do you take out your card to buy coffee? Do you remember? Do you actually know like how many times you ever went like to a Starbucks or a Cielito or like whatever other coffee shop that you might go and buy you some coffee? Like you probably don't remember. Like you probably have a very good like ballpark estimate of how many times a month do you go, but it's actually pretty hard to remember like how many times you go a month. Well, guess what? Banks, they have that information. Whoever has your credit card with, so being Banorte, American Express, Visa, MasterCard, whatever, like they have that information. They know how many times a week, a month, a year, since the first time that you had your credit card, you bought a cup of coffee. Not only that, they also know how much you spent on coffee. Maybe one day, like you were particularly happy and you splurged and you treat yourself to like a very expensive cup of coffee, and maybe some other times you were very strapped for cash and you bought like the most basic coffee that you could. Well, the bank also knows that because the bank is the issuer of the card, and the bank knows all the transactions that are being done with the card in real time, day by day. So the bank knows exactly when you like to go and buy yourself some coffee. Let's make it clear, like the bank doesn't actually know which kind of coffee do you want. Like they only know that you paid coffee or you paid in a coffee shop. But now the bank knows something very intimate about you, something that probably no one else in the world knows. Not even like your partner, your sons, your daughters. Nobody knows how many cups of coffee or how many times you go to a coffee shop, but the bank does. Like, let's go back to that question, like the last 3 card transactions, like maybe it was a cup of coffee, maybe it was a movie, maybe you went to a movie theater, maybe you went to like the first showing of like a Star Wars film, like, or I don't know, you went like to watch another movie. Do you remember how many times you've been to the movies? Like not recently because they're closed right now, but do you remember how many times you went to the movies last year? How much did you spend on each of these times that you went to the movies? Of course, you paid for the tickets, but you also paid for the popcorn. You also paid for the soda. You also paid for transportation. Do you know how much of your monthly budget is allocated to going to the movies? So probably you don't know it. Probably it's very hard for you to know how much each month or each year are you allocating for going to the movie theater. But guess what? The bank also knows it. They know how much you spend. They know if it was spent in the grocery stand. They know if it was spent on tickets. They know if you pay the tickets online, or they also know if you pay the tickets like in present, like in the actual movie theater. They know which time you paid for the tickets. So now the banks knows how often you drink coffee, how often you go to the movies. 2 very personal things about you, and the bank actually knows pretty much to the minute about all of these transactions. And remember, I said 3 transactions, so let's think about the third one. Last time you paid something with a card. Maybe you paid for some, like, for your electricity bill. Maybe you paid for gas. Maybe you pay like for your water bill. I don't know, like some kind of service. Something that you have to pay month by month. Something that usually only you and your provider, being like the electricity company, the power company, the water company, the phone service, like whoever is your provider, usually only you and your provider know about it. Guess what? The bank also knows about it. The bank also can see all your transactions and see each of these transactions, how often they happen, how periodically they happen. And they can know month by month if you're spending more or spending less in electricity. You're spending more or spending less in water. You're spending more or spending less in gas. And depending on how complex this is and like how deeply you want to go into the data, well, you can start to infer things. If 1 month you were almost spending no gas, and the next month you're spending like 3 times gas, well, it probably means that you're cooking. And if you're cooking, it probably means that you're buying things related to cooking. It means that probably your lifestyle is changing. It means that maybe now you're going to Williams Sonoma, Liverpool, or these other stores to buy like cooking utensils. Maybe you're spending less eating outside. So with these very 3 examples, we're coming to the conclusion that the bank with whoever you have your credit card, and I'm only talking about credit cards right now, knows a fair bit about you. Knows what you like to drink, like where you like to drink, knows which kind of entertainment you enjoy, and also knows about like some of your habits in terms of like your daily life and how you procure yourself like different services. And because a lot of people here is like into machine learning data and things like that, you can actually start thinking about like all the cool things you can do with all this data. You can probably think about like all the different ways these data can be used to help you, because not even you know this data. Like you don't have a perfect record of like all your expenses. You don't have a perfect record of like how much of your budget you're spending in different services or in different entertainment, but the bank does. And that's actually the point of applying machine learning into financial services. That's actually the point where we actually want to see like how machine learning can help us further and give better financial services to people. And to actually show a little bit of my point, I would actually like to share. I love this part of the presentation actually. Okay, so I'll share a different screen. I know this is a little bit like my talks are usually a bit different from traditional like conference, like academic conference talks. So this is like McKinsey. McKinsey is a company, they do consulting. It's one of the largest consulting companies in the world. Probably heard about them. And they have an estimate of how much artificial intelligence is going to impact the world in terms of money. Okay, not in terms of like actual like social impact, but in terms of money. And I love this visualization. Like I hope all of you can see it. Like if someone can please open your mic and tell me like, yeah, we can see the visualization. Can you see it? Yes, no, maybe. Yes. There's a couple of, yes, okay, perfect. There's the chat. There we are. Okay, so depending if you're working or you want to work later in the industry, like here's like different, like how artificial intelligence, machine learning, basically, like probably we all here know that machine learning is basically what's being used, not actual artificial intelligence. How is it impacting different industries? Like we have retail, we have public sector, and we have banking. Like this is what we're talking about. Okay, so basically, like McKinsey tells us that banking has about a $1 trillion potential a year, like of growing up the banking business. And some of these things we're going to talk about, and we can see like it's applied to marketing and sales, like giving better products, designing better products, which is like some of the things we're going to talk about. Risk, like reducing the risk, human resources, like better hiring in the banks, finance, like actually like traditional Wall Street finance and like other kinds of operations. So we can see in this visualization that artificial intelligence already has a huge potential in banking. And it has a whole gamut of different applications, different pricing, churn reductions, like have people have less churn in our services, have a better CSM, like customer service management, have better customers, have better customer acquisition, like all of these different applications. And if you click in all of them, you're gonna have like the kind of machine learning techniques that we can use for these applications. And this, what we're looking at right now, is what pretty much every bank, regardless of size in the world, is doing. Because banks already have the data. And we're going to talk about it, like which kind of data do the banks have. Okay, banks already have data. Banks already know, like basically what they need to know to generate these insights. So right now, the world of finance is one of the worlds that is most, let's say, most ready to apply artificial intelligence. One, it has data. Two, it has money. So like those two are like it's a very, very nice combination. Like there are some industries that have like a lot of data but no money, and some other industries that have like lots of money with no data. So it's like finance is like the perfect combination. Okay. So let's go back to our presentation. So we talk about this, and at the end of the day, what kind of data does the bank has about you? So it has kind of data which is called your transactional data. Your transactional data is basically what we talk about. Like each and every transaction that you make with your credit card, with your debit card, with whenever you're transferring money from one card to another, like all of these is the kind of data that the bank has. And well, if you use your card pretty often, it's basically your life's data. It can infer which kind of lifestyle do you have? Like perhaps you like cooking, perhaps you like to buy ingredients in like fancy grocery stores. Perhaps you like watching Netflix. Like Netflix, you have to pay Netflix with a credit card, right? Like you have no option. So like perhaps you like Netflix, or like the bank also has information of Netflix. And perhaps you like eating out. Perhaps you don't actually like to cook for yourself. You go to restaurants. So in restaurants, usually you also pay with a credit card. Okay, so all of this is called your transactional data. And this kind of data is some of the most important data like a bank or any institution that can have. Like obviously, this is not exclusive of banks. Like for example, if you are with Uber Eats, for example, like they have all your data on which kind of food do you like, which kind of food do you like to order. Like that's your transactional data on eating, basically. If you have I don't know, like other kind of service like Uber, like traditional Uber, like they have all the transactions in terms of like where do you like to go, where do you like to come. But banks, they have this very interesting mix of data, which is like they have the Uber data. They don't know the distance, they don't know the destination, they don't know the origin, but they do know the amount of like in US dollars. And they might not have the data of which movies do you watch on Netflix, but they know you have a Netflix subscription. They know that perhaps you are willing to pay an extra tax for Netflix or no, and like maybe you cancel it. They also know about it. And finally, they might not know which ingredients do you use to cook, but they do know that you like to cook. They do know that you like to go to fancy places where they sell like cooking utensils, like Williams Sonoma or like these kind of fancy stores, and you go very often to those kind of places. So it's a fair bet that you like to cook. So all this transactional data, it's available for pretty much every bank that has a credit card associated to it. And also the credit card issuers like Visa, MasterCard, and American Express. So, and the thing about these lifestyles that we know right now, like we we already grounded that different lifestyles, different people have different lifestyles, and banks can actually infer those lifestyles. Well, it turns out that these different lifestyles, they have also different financial needs. What do I mean by that? Perhaps you just finished college, and the moment you finish college, well, like you don't actually want to buy a house, you don't want to get a mortgage. So, but perhaps you like to party out, perhaps you like to eat out. So perhaps you need a credit card that is suited for those needs, that can give you better rewards if you go to restaurants, that can give you better rewards if you go to holidays, that can give you better rewards if it suits your lifestyle. Perhaps you like to do a lot of sports and you actually always never go to restaurants and you never go to parties. And so a credit card that gives you a lot of like restaurant like promotions, like it's of no use to you. Perhaps you want a credit card that rewards the fact that you like sports. Perhaps it's a credit card or it's a financial service that comes with a healthcare package that you can go periodically to see doctors like physicians that are focused on sports, and then they can help you like to have a better performance in whatever sport you're doing. Perhaps you're a professional chef. Perhaps you are looking to have a new house, and then you have needs of different financial products. And the problem, pretty much with every industry, not only banks, but the problem with every industry right now is that we actually, all our products, we give them as a blanket. Pretty much every client gets the same product. Every client has basically the same alternative. Like we have some leeway, like in terms of like some credit cards are very suited for traveling, and some other cards are very suited for having like a lavish lifestyle. But pretty much all the credit cards are built the same, like rewards and all. Like we don't really have that many different services, but with all this data, we actually could. And again, the idea of this talk is kind of push you into that direction. Like we're not gonna see like how can we get into that particular place, but like the idea of the talk is like push you into that direction. That you know how to get there. Like you do due to the nature of this conference, like pretty much all of you already know like things about machine learning, artificial intelligence, and this talk is pretty much to show you how you can use those techniques to apply them in the financial world. So up until now, like, does anyone has any questions or like inquiries or some of that?
Well, maybe I have some few questions. I don't know if this is the best moment, or do you prefer at the end, or maybe now? For example, let me. How much do the banks and stores exchange information, specific information? For example, in a purchase receipt, do they share all the list of products from a ticket, or is not exchanged? What is the level of information?
Sure. Well, usually what happens is that whenever you pay with your credit card, if you remember, the only thing that you see when you pay in the credit card is the amount in pesos, in dollar. So that's the only information that the bank gets. Like, where are you paying and how much you're paying.
Because
yeah, like the items, like only the store has that information, like which kind of items were bought.
Yes, because from a coffee store, well, it's well known that you are buying coffee, but what kind of coffee? You don't know what kind of coffee, but just the quantity. No?
Yeah, sure. Yeah, but it's well, in terms of lifestyle, it's not the same to buy from a coffee store in like a random coffee store, like on a 50, like a 50 peso coffee in Starbucks. So like you have like different lifestyles there.
But this is also a challenge for the other companies, for the store, who they need also to develop the machine learning.
Oh, yeah, sure. Yeah, like I mean, Starbucks, for example, has some of the best data science teams in the world. Like,
Yeah.
and many other like companies, like retail companies, they also have their teams like doing whatever they can with the different information that they have.
Okay. Is there more questions from social networks? Is there any question?
No yet.
Not yet. Well, that's good. That's good.
Okay, perfect. So let's keep going. I love to talk about this example. There's like a very old bank in the United Arab Emirates called NBD. So it's one of the oldest banks in the world, like really, really old. Like it's probably had like more than 60, 70 years. Like it's what you will call a legacy bank. And they just released an app called Live. And this app is basically a social network. It's like kind of like a Facebook. Hey, and you can share what you're doing and you can share pictures, and like people will ask like, okay, but what does that have to do with the bank? Like, why would a bank release a social network? And it's basically the same thing that I've been talking up till now. Like banks have to change. Like the way banks acted until now, which is basically as places where you can borrow money from or places where you can put your money in, they have to change that. Like that, those kind of services are starting to be provided by like not so complex companies, like for example PayPal or like many other of these online banks. So they actually have to change like the way they're doing things, like the banks. So Live is an app that basically matches your lifestyle with your banking. So they track all your transactions. And the next time that you're near a Starbucks or like you're buying a Starbucks, you're gonna get you get a notification in your app, and they tell you like, oh well, if you pay with your credit card right now, like you are gonna get like 5% discount, or you're gonna get way more points. And the next time that you're going to a retail store, they're gonna tell you like they're gonna send another push notification. It's like, oh, like we noticed that you're in a retail store, and right now is a good season to buy because there are like many discounts. So perhaps you would consider going to the store, or perhaps that you're near the cinema, you want to watch a movie. The app is gonna send you a push notification and tell you like you're already way over budget. Like you should be careful of how much you're spending this month because these going to the cinemas is like it's going over budget. Like you probably can't afford this. So these lifestyle apps are basically trying to do two things. One, to optimize the way you use your financial services the most. If you have a credit card, and perhaps you can do tons of things with that credit card that you didn't know. And the app actually helps you do that. The app helps you build, like, do all these different things. Maybe it has an insurance associated to it. Maybe you can go to the dentist with your credit card and have like a special promotion and you didn't know about that. So like the app basically helps you do all of this. But the app also helps you manage your finance. Like right now, some of the banks in Mexico and in America, you can see like tells you like, oh, you're spending this much in food each month. But with this system, you can basically get direct notices that you're spending like way too much on food and like on eating out. And perhaps you should be wary of that because you're gonna end up with a huge debt that you might not be able to pay. So banks no longer are like the holders of the money, and they no longer are only like places like you can get a credit card from. They're places that are trying to help you actively to achieve or to reach whatever financial goals that you might have. via banking, via saving, via investing, via just like having a better like financial life, like not spending as much money as like you have a credit card with a ton of credit limit, like perhaps not use it all of it in one go, perhaps using it just like little by little. So this bank, like this bank in the middle of the Middle East, it's basically showing the way like many of the banks in the US, in Europe, and some of the banks here in Mexico are starting to go. A more direct relation with your customer. For what do we need that direct relation? Well, to have a better understanding of our customer, like what do they like to do, what do they don't like to do, where do they like to buy things, where don't they like to buy things, so like these kind of stuff. So this app basically like opens the door to all of it. And why is it so important to open the door to all of this? Like I've been talking about like banks having all this data, to banks basically being like this entity of change, like they are changing all these. And why? Like why banks have to change the way they're doing business? Like they're making money. Like why would they need the way they do business? And that's the answer is actually in this plot. So they're like, this is like a focus group base, and people asked to millennials in the United States how often they go to bank branches. Like bank branches are like basically like different places, like physical locations of banks. Like how often do they go? And this is 2015. This was like 5 years ago, like before the pandemic hit. Like probably these numbers are like way more biased right now. And 38% of millennials say that they don't visit a bank. And this is people that are like well within their earning years, like they are earning money. These are not college students. These are not people that are not working. Like these are people with steady jobs. And 38% of them do not visit the branch. 26% visit less than one time a month. 10% is just like one visit a month. Another 10% 2 visits per month. Another 5% 3 visits per month, and like the rest of them like 6% 4 or more visits per month. So this means that about 50% of your millennial clients, they're pretty much never go to the branch. There's like no way they go to a branch. Like pretty much whatever they can do in the branch, they can do it in the online banking or the app on an ATM. Okay. And I would like to pick, I would like actually to pick your interest and like to think, why is this important? Why do you think this matters to the bank? And why do you think this goes hand in hand with whatever I was talking before, like this change the banks are undergoing? Like, why do you think this plot is so important for banks? Like, you can answer in the chat, for example, if you don't feel like talking. Someone in the chat. The amount and the store, right? Come on. Why do you think it matters so much? Like, this is a tutorial. Like, this is not a tutorial. So that's the reason I'm asking things. Like, you're like, because they will need less and less branches and peoples. And what does this mean? Like, why is having less physical space is important? Money, of course. Yeah, so if you ever see the no more visits, but the behavior. So if you ever see the balance sheet of a bank, like whatever bank, like Bank of America, Banorte, Citi, like whatever retail bank, you are going to see that some of the most of the expenses, they come from the physical locations. They eat up like more than 20% of the expenses of the bank. Why? Because they usually don't own the physical locations. They have to lease the space. Leases are pretty expensive. They have to pay people for being in those spaces. But the thing is, like, in 10 years, when like most of the people, when most of your clients are going to be millennials, like when this time happens, like this is probably means that most of the people are never gonna visit a branch. That you're gonna be spending money in a physical place that no one is going to visit. Like no one is gonna go to the branch, no one is going to do business in the branch. And to make decisions, like, so no one's gonna do business in the branch. So basically you're spending a lot of money for a space that is not being used. And what do you think, and I already told you, what do you think is happening to all the operations and all the transactions that were being done in the branch? Like taking money or like opening new accounts. What do you think is happening to all of that? Like, where do you think it's going? Like, why are people not going to branches anymore? Like, is it because people don't like going to places? Like, they don't go into the bank? Like, I can't recall anyone like enjoying going to the bank. There are new ways to make transactions, the use of digital banking and e-commerce payments without using a credit card. Like, exactly, like we have less and less need of actually going to the bank. Like, we don't need people to interact with. We can do pretty much, it's easier, like Enrique here is saying, like it's easier to do all the transactions if we use our app, our mobile app. We can send money, we can receive money, we can, that like pretty much the only thing we need to go to a bank regularly is to get cash from an ATM. And even that, as like we're moving towards digitalization and more credit card use, like it can be fairly assumed that cash is going to die. Like not in the near future, but in the long term, cash is going to die. Like no one is going to use cash. You can go to China, pretty much everyone pays with their phones. You can go to the US in America, and also you can pay with your phone or with your credit card. Like you don't actually need cash. Like when I was living over there, there could be like 4 or 5 weeks without ever needing like to have like any physical money with me. And like pretty much I could pay everything with a credit card. So that's the reason branches are going down. And the thing is, like, we're not only losing the branches, but are we also losing this personalized touch of knowing our clients? Like you can't talk to the client anymore and see like how they're doing, like for this more personal banking. And we have to recreate that knowing the client, and we have to recreate it using data. And which kind of data are we going to use? Well, like all the data that we know about our client. So financial services, pretty much every financial service is moving from physical to online transactions. Not only that, like this is the paradox of financial services right now. Like people want everything to be online, to be unpersonal, while having a more personalized service. We want our Google searches to be like whatever we want them to be. We want our Facebook feed, whatever we want it to be. We want our Twitter feed with whatever we want it to be. But we don't want to deal with the hassle of like dealing with someone and like having this personal interaction. So there's a kind of a paradox. For example, we want to be able to invest, like to invest in companies. But a lot of millennials, like a lot of young people, they want to invest in like companies that are devoted like to know like the betterment of the planet. So we have these products called the green ETFs, so like it's like equities basically, and we can have only stocks that are based on like companies like electric car companies, these kind of things. So we need new services like for investments. Like people don't just want your money to grow randomly. They want to grow with a motive, like to grow with a targeted actions that can actually like make you feel good, not only like making money, but actually can make you feel good because you're helping people. We want personalized products. We say like, yeah, we want a credit card that's suited to our needs. And how do you know our needs? Because you're not going to the branch anymore. Yet I do want you to know my needs. I need a loan, and I need you to know exactly which kind of loan do I want, which like the rate that I'm gonna have. Your investment portfolio, like which kind of portfolio would you like? But again, I don't want to be in a branch. I want all of these to be automatic. I want all of these to be decided by an algorithm or by someone else, but I want it to be just for me. I don't really want it to be like part of like these huge transactions where everyone gets exactly the same product. No, I want something very personalized. I want something that is just gonna go for me and nobody else. So we're moving from physical to online transactions at the same time that people are looking for more personalized banking and financial services. And this is an issue. This is an issue because, well, like basically everything becomes ones and zeros. Like we no longer have the capability of talking with our customers. Okay? And with that in mind, I would like to take a break right now. I always think like 50 minutes, it's about the like in my business school, they usually make like 50 minutes, the perfect amount of time. They said like no more than that. I would like to take like a 10-minute break, and then we can change to the next part of the tutorial. Is that
Very
fine?
good. Very good, Leon. Very good. Okay, we have a, a break. Of course, the social network and this chat is open, so we can receive new questions, which will be attended by Leon in a few minutes. Okay, Leon.
Okay, cool. Thank you. So yeah,
Welcome.
I'll start answering whatever questions you may have. Thank you. Hello?
Hello,
Hey there, Oscar.
we're back.
Hi there, we're back. So do we have any questions or
No more questions. No more questions.
No.
Is there questions? No more questions by the social network.
Okay. Well, this is a tutorial. Like, people should be asking things. Cool. Oh, let me share again my screen. Cool. Okay. And right. Perfect. So we already talked about the motivation, that why are banks and why is basically the financial world so invested into learning about things like doing machine learning, doing artificial intelligence. Why is there like this very big push for using all of these techniques out there? Like, why are they capable of doing them? So now we're going to basically explore like the applications that they might have, the kind of data that maybe they might use, some of the restraints that they might have on the data. Like, people actually see it from the outside and they think like, oh, like people have all of the data. Like, you know how many times I heard about like how Facebook sells our data, and people talking about like, yeah, because Facebook sells our data to everyone, and like that's not true. Like, Facebook doesn't sell data. Like, they do make money. They do make money using our data. That's a fact, but they don't sell it. Like, they're not allowed to sell it. And in Mexico, it's the same thing. Like, we have a law that prevents banks or any institutions from selling or sharing data without we the people being in the know of like that happening. But so we're gonna see like some of the restraints, some of the problems in machine learning right now in banking. Okay. And the first set of problems, it's a problem that we all know very well. It's pretty much 80% of problems in banking, and they fall within the realm of supervised learning. Okay, it's the most common kind of learning. Probably most of you know. If you don't know, you know this is a tutorial. So supervised learning is that learning where we have targets. We already know, we already have labels of what we want to predict. Some of the most basic examples of supervised learning are like spam detectors, are like basically pretty much like every classification problem is supervised learning. So it's one of the most basic problems in machine learning. It's one of the first problems that we ever learned. The first time we start learning about machine learning, it's they're interesting problems. And in banking, well, we have tons of problems that use supervised learning. Okay. The most basic problem is like credit score and loan allocation. Okay, so imagine that you are a bank, like you have a small bank yourself. Okay, so you give loans away, you also give credit cards, and you have a new client. Okay, and you have to determine somehow how good is their credit rating going to be. And if they're looking for a loan application, like how much should the loan amount be? Like how much should you be loaning them? Okay. In order for what? In order to prevent default, that is to prevent them from like failing in their payments. And in order for what? In order like for them like to be actually to achieve whatever they're looking for. Like if you're asking for a loan, perhaps it's like for a new car or like to open a new business. And of course, like you want, like the bank wants to help them like to some degree, but you also want to be able to know they're going to be able to repay the loan. It is extremely risky for a bank to grant loans to very high risk individuals. Like if someone comes and they don't earn enough money and they ask you like for $1 million loan, like you're basically not gonna give them to them because like way too much money and they're probably not gonna be able to pay it back. For example, we have the credit score, like in Mexico, for example, we have the credit bureau. In the US, they have the FICO score. There's like all these different scores. And the thing is like they're so basic and they're so simple that they can be easily tampered with. Like it's very, very easy to have a good credit score here in Mexico. Like you just have to know how it is calculated, and that's pretty much it. It's not hard to have a good credit score. And one of the problems with new clients, like if they've never been in the bank, is like we don't have any transactional data. All this data that we talk about, that is beautiful, that it's great, about like how many coffees do you drink and like how many times do you go to the supermarket and all of these, we don't have it for new clients. We usually only have some demographic data, that is like whenever you're asking for the loan or a new credit card, like they ask you to fill up things in a paper. And that's pretty much all of the data that you have. Some demographic data and some personal information, okay? So in terms of machine learning, and I just put it aside so they don't say like I'm not being rigorous enough. So the bank, with all of its clients, already has a manifold, like of all the clients, okay? Pretty much every client in the bank, it's being profiled given their transactions, their gender, their like all the different data that we have at the bank, and we have them like in different places, right? Like we know, for example, that this guy, like he pays his loans like very on the first days of the month, and he has a credit card, and he also has like a card loan, and also has a mortgage. Like we have all the information, and we know he's a male and that he's like about 50 years old, right? And we know that she over here, like she's been working in the same place like for 5 years, because here in Mexico we have information about like where are they being paid from. And we know like she likes to go to restaurants, and we also know that she's like 35 years old. And we have all of this information for this client and for this client, okay? So we have a new client. So the problem at hand is that we have a new client, and we actually already know which clients are good and which clients are bad. So we want to know this new client, whether like he or she looks like the good client or he or she looks like the bad client. Because that's the main problem. But the thing is, like we don't actually have credit card transactions. We don't actually know whether like he or she is being paid periodically. We only have their word. We ask them like, okay, you've been paid. Sometimes we ask for income stubs, like the receipts that they have, and then we have some degree of certainty that they are actually working and they are actually earning the money they say they are earning. But many times we just take them by the word. Okay, banks is like, how much you earn? Oh, like $50,000 a year. Okay, that's about right. Okay. So the main problem in the bank here for allocating loans and giving good credit score is to have this new client mapped via function F to like some place in our bank manifold, okay? And this is just a fancy way of saying that we already have all these supervised candidates, and we actually just want to classify this new client, okay? Like this is like one of the oldest problems of machine learning, where you just want to allocate this new client in whatever data we already have. And which kind of data do we have? So which kind have two kinds of data. One is demographic data and the other one is transactional data. Transactional data, we don't have it for new clients, okay? These, like, we don't have it. They don't have any products with the bank. They're new clients. We don't have any purchases. They don't have any payment history, okay? Perhaps, for example, you can ask for a credit check, and then you have some degree of knowledge of whether they pay their credits on time or not, or like whether they have a car loan or on any other kind of financial services. But then we do have the demographic data. Okay, we do have the age, we do have the gender, we do have their address, like where do they live, and we also have the race. And here with the race, we actually hit a very sensitive point. Okay, which point do you think it is that we're hitting with this? So and this is an open question. Again, this is a tutorial. I really expect you to participate. Which ethical issues do you see with using racial data for a prediction algorithm in terms of like of giving away credit cards and loans? And I'll check the chat, at least like answering the chat. So like there is a person described something like. Well, we have a question from Bernardo. Okay. Oh no, it's like from Alex Costa from Facebook. Okay, Alex Costa asks us, I've heard about the new financial groups that are not exactly banks, they're fintech, like Nubank in Brazil. They're using machine learning to determine whether a person gets a credit card with them or not. Is it something like actual banks in Mexico are doing? Yes, banks in Mexico, like they're doing this kind of stuff, like they're like allocating products using machine learning. And basically fintechs in Mexico, they're also doing the same thing. And Oscar, to answer my question, like which ethical issues which ethical issue I see with using racial data? It's an ethical principle, yes, but why? People like to say like it's an ethical principle, but yes, why? Do we take it at face value? What's wrong? Like accuracy using racial data, it's like it's over the top. It's one of the best accuracy you're ever gonna get. Like, why can't we use it? Why should we sacrifice accuracy by not using racial data? Like, why do you think racial data is so sensitive? No one? David, let's see what David says. Probably, I think there is a problem of using racial data. Problem is interpretation we gave to the patterns. That sounds off. I think a problem with interpretation because of the bias. Yeah, like we do have bias, but again, the accuracy is great. Like I'm playing a little bit of devil's advocate here. Like it's a matter of fact that using racial data is good for the algorithm. That's just take it to the bank. That's just the truth. But why should we avoid it? Why should we not use this very good feature? Like if it's such a good feature, like why should we avoid good features? Like that goes against pretty much everything we learn in machine learning. And that's part of the reason of this tutorial. Like we look for getting better and better algorithms with better and better accuracy. Here we have a great accuracy. Here we have an algorithm with great accuracy, but we're using racial data. Okay, why maybe in banks and like many other applications we shouldn't use it? Good motivation to improve accuracy, but I would no doubt that in practice it is carried out. Okay, so like the thing about racial data is, well, the answer I was fishing for is that it perpetuates discrimination. Particularly in America and here in Mexico as well. Like you have people think about the people who don't have bank accounts or that have very like a very small like credit history here in Mexico, like don't even go to America. and you can think in like native people from Mexico, right? And like these native people in Mexico, like probably they don't use banks that much, and whenever they use them, it's like, oh yeah, but you don't have like any history using banks, so we won't give you such a good credit. If we associate that lack of credit with like your racial profile, basically you're doing discrimination, and you say like, because of your racial profile, I won't give you this credit, and won't give you that much money. The accuracy is going to be like very, very good. But basically, the classifier is perpetuating systemic racism. And we actually don't want that happening. We actually are trying to avoid that from happening. Okay? We don't want our classifier, we don't want our machine learning system to perpetuate racism. And that's the reason, like in many places, actually, it's forbidden to use racial data. Okay? So like that's the reason like we actually try to avoid racial data over there. That's the reason I crossed it out. We don't have it as data, but we try to avoid using it. Which other biases do you think can exist, like other than racial data? Which other biases do you think that might exist with demographic data? Like whenever you're asking people, like which other things do you think like we should take care of whenever like asking people from their data, like racial, like Fernando, because the algorithm is just an statistical model, but in real life there are cases that do not fit the model, and this should be considered at the time the system is built. Otherwise, the ethical issue is not the fact that the system is being racist, but it was designed with thinking that this can happen. Well, I mean, the system is being racist, like it's perpetrating racism. I mean, I agree that the system itself is not racist, and we can actually make it not racist by just taking off that particular feature. So which other biases do you think they exist with demographic data? Or do you think there aren't any more biases? Do you think like algorithms just should take all the data they can and just like make the best predictions that they are allowed to do? For example, I can think about like some like sensitive topics, like for example, the address, right? Like where do people live? Like maybe that particular feature might be like might discriminate some people just because they don't live in a well-off neighborhoods. Even the gender, right? The age, like they won't give that much money to someone like very young, and they might be just because of the age they might discriminate towards people who are older people. Okay, so there are biases pretty much everywhere, and it's within our field as like machine learning practitioners, as machine learning researchers, to actually try to account for those features, to actually kind of count for those kind of issues. Let's see what Jorge says. Another common kind of demographical bias is that traditional banking is more inclined to lend money to men than women. That's just what I said, like gender. Those without any kind of data filtering to reduce bias, this historical trend will be replicated with a bias prediction algorithm that takes gender into account. Yeah, basically it's same as racism, it perpetuates the system. It's not that the algorithm is racist, it's not that the algorithm is it's discriminating men against women, it's just like using whatever data it was fed with. Okay. So this data is like extremely important. Like we have tons of data in banking. Like we have to be very, very careful about what data we're using. Next, basis. So we do have some constraints in banking, and there are like some other industries that where the algorithms might have some issues, like using algorithms to make decisions. Okay, most of the time, that like depending a lot on the application, most of the time, the algorithm must be interpretable. And this means that deep learning, like a lot of people love deep learning. I mean, I like it enough. I like it well enough, but it's out of the question. Why? Because deep learning by definition learns some abstract representation of the data where we actually do not know anymore, like whether the data is which kind of like which features actually bring more informative or not towards the classification. So if we're giving a new credit, if we're giving a new credit card, and we're using deep learning, and some regulatory agency comes and asks me like, okay, how much does the income matter on you giving a new credit card? I tell them, I don't know, like it goes into the deep net, and that's pretty much it. Like I don't know what happens afterwards. So that's a no-go. Actually, like if you try to sell a system like that in a bank, in many financial institutions, that basically like won't fly. So, and this is to tell you that you can't, or maybe you can, use deep learning in banks. You can to a certain extent. There are certain tools that we're gonna look a couple of them, but like just like out of the box, you can't use deep learning in a bank. You have tons of data, and that's beautiful, and maybe you can use it for some other applications. But for the particular application of giving loans and like actual interaction with the clients, like giving loans, credit cards, and that kind of stuff, like you can't use deep learning. Again, why is that? Because the decisions have to be tractable. Even though they're being made by a machine, the way the decision is being made, like which variables are having the most influence, it has to be tractable. It has to be explainable. You have to be able to say that age plays this role in the classifier, and gender plays this role in the classifier, and income plays this role in the classifier. Like you have to be able to do that. If you're not able to do that, your system won't be used in the bank. Okay, we won't be able to use it because, well, it's not good. And speaking of which, then, like which kind of systems are used in banks, right? Like which algorithms are being used in banks? And here I open the floor again for questions, for a little bit of discussion. And I already told you that it's because regulatory agencies ask us to be tractable. But why do you consider algorithms must be explainable? Why can't algorithms just be black boxes, even if they're very, very good? Why do you think algorithms must be explainable? Like, why do you think explainability is like a nice thing to have in machine learning? They can be expressed in terms of business rules, like they can go in line with business rules. Well, tools such as LIME, SHAP, values over exist for model decision and tools like this being considered within. I'm gonna talk a little bit about them, and yeah, like they're being considered, they're being used. It's part of the science method in order to determine which features are really important. Okay. Okay, so algorithm must be explainable because, well, we want to know which features actually help us. And also in terms of banks, for example, if you already know that income is very important, perhaps you can design a new product where income is not that important. Like you as a company have that freedom to design the products like the way you want them to be. So if you already know that income is a very important feature, perhaps you can make it in such a way that you don't need a higher income to get access to a better credit card. Again, I told you, is you have to make a personalized product. The next question is, what do we gain out of explainability in the algorithms, which is, well, pretty much people already answered that. And other than explainability, which other constraint do you think that should exist in in these kind of classifiers, other than if they being explainable. Like we already talked about, like biases. We already talked about explainability. Do you think there are any other constraints in the algorithms, or can I just take like my library and apply it and just go on with my life? No constraints? Well, I can think of a couple of them. For example, algorithms, for example, probably should be fast enough. So the moment you have a new client, you can make a classification. Algorithms should be flexible enough, such a way that you can retrain your data very, very periodically. Algorithms should be good enough that they can work with tons of data and they can be retrained constantly. Algorithms, for example, they should be explainable. We already said it. Okay, so a lot of these issues actually, like, and this is what I talk about, like which alternatives do we have? Okay, which algorithms are actually the ones that are being used the most in like financial services, like banks and different kind of financial institutions? Logistic regression. Like, believe it or not, like logistic regression is one of the algorithms that are being used most, and it's causing linear regression. Like even with our fancy like new deep learning and like all the different regressions and classifiers that we have, logistic regression is like it's surprisingly powerful. Why? It's good. Like it's really, really good. And as we have more data, it's also really efficient. It's very efficient to train. You can basically do like gradient descent and gradient based methods for the optimization, and it will work wonderfully. You can optimize it using GPU and using TensorFlow. You can do logistic regression with TensorFlow and like run it really, really fast. You can regularize it very, very easily. Like regularization, like this is a tutorial on banking. Like, well, I hope you know what regularization means. You can regularize it very, very easily, and it's very easy to explain the variables in logistic regression. Like they're very natural to explain. And if you have more than one class, you just have to change your logit function for a softmax, and then you have like a multi-class algorithm, like in a very organic fashion. So this is just to say, like I hope there's like many students over here. I mean, this is a tutorial that you don't need to apply the fanciest and more like state-of-the-art algorithms out there, like in the real world. Like good algorithms, like these kind of algorithms, like logistic regression, linear regression, they're good enough. Okay? Like we're not trying to achieve like 100%, like 99.9% accuracy rates, because we just need it to be good enough. For example, like you can have like 70s, 80%, and that's good. But you actually just spend like a couple of weeks doing the model, and then it's ready for production, and then like it has like some tuning. But yeah, believe it or not, like your logistic regression is like one of the more widely used models in machine learning, like in banking and like many other applications actually. Okay? Like the fact that it's based on gradients is nice. Optimization is also very, very fast, and it can work with tons of data. Okay, like logistic regression can work with tons and tons of features, tons and tons of data. Okay, so this is probably one of the models that are most widely used in the whole world. Like in that McKinsey presentation that I showed you at the beginning, in that presentation, it says like logistic regression can be used for solving many of these issues. Okay, so we have logistic regression. Another alternative over here, and this is very, very popular, it's decision trees. You heard about decision trees. Decision trees are nice because they're very intuitive in terms of the explainability. Okay, like how different variables explain the classification. It's very intuitive in decision trees. So you can see people use very often decision trees. They use pretty often random forest, and they use pretty often XGBoost. XGBoost is nice because it's fast. It's crazy fast. It can be optimized using the GPU. It's been proven that optimizing the gradients instead of optimizing the cost is like gives very, very good results. And it's very intuitive as classification for regression. One of the main problems here, and it also happens with logistic regression, is that people love to use algorithms as black boxes. And I can't tell you enough of how wrong is this, like to actually using algorithms black boxes. Okay? And it happens pretty much in every industry. Okay, it also happens in science. Like I'm seeing like social scientists and like physicists and like use algorithms, like machine learning algorithms as black boxes. Okay, and this is not something that we're looking for. Something that we want to happen. Okay, for people to use algorithms as black boxes. Because why? So nowadays, there are many vendors that they promote something called AutoML, auto machine learning. Okay, this AutoML has like many nice to have features. Like some of the features are like the models are ready to use. You only put your data, and you actually don't have to do any hyperparameter optimization. You don't really have to tune the model for the data or anything like that. They promote them as ready to use models. Like you don't actually have to do anything else. They're like very big vendors that say this, that oh yeah, you can just use AutoML and life will be beautiful. And there are like many small vendors that do the same thing. They also like to boast that the models, they don't need any expert. And the model will auto-tune themselves. That the only thing you have to do is deploy the model, and the model will do everything by itself. But the reality is that we are actually far from such scenarios. We are actually far from this. And we still need skills on machine learning to be able to use these models effectively. We still need to know what a gradient is, what an optimization is, what a feature is, what a data transformation is to be able to use these models effectively. I'm not saying that AutoML doesn't work. Actually, there are like many libraries, like AutoML libraries that work very, very nice. But you need to know what's happening behind. You need to know why these black box algorithms aren't like the panacea that they're like they're claiming to be. Okay. Can any of you, like I open the forum again, like if someone can answer in the chat, can any of you think also why an AutoML algorithm wouldn't be a good idea for a bank, for example, or like for a financial institution? But like why wouldn't it be like in the best interest of the bank and the clients to have an AutoML system doing all the decisions? Let's see if like someone has like an interesting answer. No one? Okay. Well, if you have any questions, like just let me know. And before going to the next part, like we're done here with the part like of supervised learning, like in terms of banking. Anyone has like a question, a comment before I jump like to the next part in terms of like supervised learning and these kind of models? Oscar here answer my question, like because the AutoML problems they seek to reduce training time and maintain generalization, which is like good and a very good answer, I think. So like, does anyone has like any questions or comments? Have I used one of these AutoML solutions? Yes. Yes, a couple of times. I've used AutoML solutions, not in the bank, but for other different applications. I mean, they're good for teaching, for example. I use them for teaching a couple of times. And they're used for very, very basic applications. But in terms like when it comes to more complex data, AutoML actually, like, it's in my experience that they're not so good. And like this is a very personal issue. I think they charge too much for what they offer. Like they're basically charging you for like a glorified research. Anyone else? No?
No, no, no more.
What platform AutoML recommender for a bank? Just like these being the top that it is, and due to like whatever, how do you call it? That is just very sensitive issue. I won't recommend like any platform. Like I can recommend like open source things like scikit-learn. I love scikit-learn, but no particular vendor. Just like that's a personal philosophy. Like if you want, like not in public at least, like if you want, we can talk a little bit more afterwards, but not in the forum. Okay. Cool. Well, and before going to, yeah, because I wanna go to a rest and then like just give the closing remarks. So yeah, because I felt like more people were going to ask things. So what we're gonna do is we're gonna have like another 10-minute break, and then we're gonna just like go to the final sprint with the final applications and final like Q&A. Is that fine, Oscar?
Fine, very good idea. Okay, perfect. We are back. 10 minutes.
10 minutes. See you in 10 minutes.
Minutes.
Thank you. Hello?
Hello, Leon. We are back.
No, we're back. So let's go for the last sprint. Okay, so before I start, does anyone has like any questions or comments? No? Okay, so we won't be further much, like we're already like 2 hours into this. I'll probably finish by, my idea was like, I thought there was gonna be like way more questions. My idea is to finish about like 6:30, maybe a little bit before, and then like just open the floor for questions, and like people want to talk to me directly or something like that. That was like my idea for the rest of the session. Just like if anyone has any questions before we keep going. No?
Yes.
Okay.
Very good.
Perfect. Okay, let me share my screen. There we are. Okay. So we already talked about like all the things about like unsupervised learning, right? Like supervised learning. Like we have these black book algorithms. We can use trees. We can use logistic regression. I mean, nothing prevents you from using like super vector machines or anything else. This is just to give you the message that even though we have so many fancy tools, like we're still using like very basic, very old machine learning tools, and with fairly good results. And now comes like the second part of the problem. Like remember the paradox that we posted at the beginning, and is that the clients, they don't want to go to the branches anymore where they can get personalized attention, but they still do nevertheless want personalized attention. So we need some way to profile clients according to their needs. Okay, we need some way to take like our whole set of clients and like match them into groups, into clusters, into something, so we can give them some degree of personalized attention that they are still seeking. Like people still seek for that personalized attention. Okay, so do we actually create a new product for each of our 5 million clients, for example? We take on like 5 million different products, 5 million different credit cards. Like it's just not effective. That's just gonna happen. Create profiles, and each of our clients will fall into one of these groups, and then we can service them accordingly. You can think, for example, that we have a group with clients that they love going to the cinemas, they love going to the restaurants. Then we can give a credit card point based on service industries. Or we have another group of people that actually like they love buying books, like they buy books all the time, so we can give more points if they go to a library or they go to a bookstore. Or we have a different kind of clients, like they have gym memberships and they often spend into sports related stuff, then we can have another credit card focused on their particular needs. But we won't have one card for people who do swimming, another card for people who do jogging, another card for people who lift weights, because that wouldn't be effective. We need to have a set number of group, a set number of clusters where people like look closely enough to each other. Okay, so we can create these different profiles, and based on the profiles, service the clients as best as possible, as best as we can. Okay. And you probably are ahead of me on this and think that first, like which kind of data do we have? And this is basically the same slide as before, but here I basically took the strikeout out of the race variable. Why do you think for this particular problem, profiling like into different groups for giving different products, race is important, and it might be an important characteristic, and we might want to use race. Like, why do you think that is? Why in the classification problem we're not allowed to use race, but here we are allowed to use race? Like, why do you think is that? Like, why do you think race here matters, whereas in the previous problem, the classification to give a lone yes or no, that doesn't really matter that much over there? Like, do any of you like have any ideas on why is that? Why is race like something that we would want to see when we're doing like this grouping, this profiling? Check. Because race is very important to cluster clients. Yes, that's right. Like as I told you, at the beginning, like perhaps we're not giving credits anymore. Like we're not taking decisions on whether clients are getting a service or not. We're looking for a way to better service our clients. And in doing that, actually race is important. Why? Because people, for example, think of like people like uh, native people from the southern part of Mexico, because perhaps they have particular needs of particular products. And if we just cluster them with with people from the center of Mexico that don't really have that particular ethnia, they might not get the products that they want. They might not get the products that they need. So actually, we do need data on race to be able to properly allocate and properly not classify but properly group these like people from different backgrounds, because we're looking to service them the best possible way that we can. We're not doing any discrimination at all, because we're not preventing them from having a service, but we're just trying to give them the best service possible. Okay, and here we also have some data about like transactional data. So which kind of products do people have with the bank, right? Do they have a credit card? Do they have a debit card? Do they have a car loan? Do they have a health insurance? Which kind of products do they have? Do they have their 401a, like their retirement account? Do they have it in the bank, right? How many purchases do they make in the bank? Like many people only are with the bank here in Mexico, for example, because they get their payroll over there, but they don't use the bank for anything else. Well, maybe you can use the fact that you have the payroll, like for giving different offers, different promotions, and the payment history. Like if you have a loan, like, well, do you pay on time your loans? Maybe yes, maybe not. If you're not paying your loans on time, why aren't you paying your loans on time? Perhaps like you're having some financial issues, perhaps something that the bank would like to know to better help you. So we have all of this data about the people that are currently in the bank. And that's the thing. This is for people that are currently in the bank. Okay, not for new clients, for people in the bank. Okay, we have all this data, transactional, we have demographic data. Okay, and usually the clustering algorithm that we use, because by now probably all of you inferred that we are using a clustering algorithm, is k-means. And a lot of people tell me like, oh yeah, k-means, but it's like crazy easy. It's like one of the most basic algorithms. It's that distance-based clustering, right? But it's very good. Like you get very good results. We can use our current client base to create clusters, okay? And with these clusters, actually, we have a new client, we can match it with the clients that we have based on the data we already have. And why do we use k-means? Because we're talking about millions of transactions a month. We are talking about millions of clients doing millions of transactions. We can't afford to do like go Bayesian like 100%. Like we don't have that much time to begin with, when you actually have to give results like by the next day or by the next week. So actually k-means is a very, very good algorithm. It's a very effective tool for clustering large amounts of data. It's optimized if you're using Python. It's optimized using several cores. If you're using, for example, things like Spark, like Hadoop, you can use k-means optimized over several computers. So k-means, it's a very good algorithm. And the use case of k-means is very, very good. And it's a very, very good example. And it's a very good example in how to cluster data. Antonio is asking, like, is k-means the most used algorithm for clustering in my job? It's one of the algorithms that we use the most. Like, we use other clustering algorithms, but I mean, it's fair to say that k-means is one of the ones that we use the most. Like, we also use text-based clustering, for example, for some other kinds of data. We also used, for time series, we used other kinds of clustering, like, whereas k-means is not very strong for time series, but we use k-means fairly often. Okay, it's an algorithm that we use. We use for a lot of different things. Okay, and so this is to say that using k-means now we can cluster like all the different clients that we have. Okay, and with all these different clients, now we can do something different. We can use something that very few commerces and very few people are doing. And I think the machine learning community and the artificial intelligence community should look into this, like, should turn their heads and look into this, because to be fair, I rarely see papers on experiment analysis in this conference, in McKinsey, for example. And right now, machine learning and behavioral economics in the world are like having this very interesting mix, and it's starting to be used in a lot of different businesses. And in experimental analysis based with machine learning, we can use our groups, like all the groups that we have right here, like we can use all these groups to run experiments. So we have our group 1, our group 2, our group 3, and this has like different clients. And I can take like 10, 20, 100 clients from each group, right? And I can run an experiment. Which kind of experiment can I run? Well, I can give them a new deal. I can show them a new message on their mobile app. I can offer them a new loan. And I can see how different clients in the different groups are going to respond to these changes. And then after doing the experiment, I can say, okay, based on the answers, I can basically say that this particular group, for example, group number 2, is very perceptive and they really like car loans, for example, like good car loans. So whenever I have a good way to give them a better car loan, I just can target it to group number 2. Or perhaps group number 3, they like to travel a lot, like we have all our business travelers over there. So I'm just gonna give them new deals on travels, and I can see how much of the deal they're gonna take advantage of, or like how much are they going to use their credit card. So experiment analysis, which is an area that really, as far as I know, is not being taught that much in many like artificial intelligence, like postgraduate education. It's being used fairly often in many institutions. We can create new campaigns that will be targeted only to those clients that we wish to affect. For example, in the case of banks like finance, we can have new credit cards, we can have mortgages, we can have car loans, and we can have all these campaigns focused, like laser focused on those clients that we want to affect. And we can see, for example, a change in the rate of the loan, how much is going to affect each group, and how sensitive is different populations to different changes in the rates. And what this makes is when we can keep the ads and unnecessary campaigns from appearing to clients who are not interested in them. And this is very important. Like, how many times have you been in the internet and you get by mail, you get a promotion? It's like, oh, you might want a loan. Like, no, I don't want a loan. No, but you might want it. Like, it's a lot of money. I was like, yeah, I don't want it. Okay, that's one of the most bothersome experiences one as a client can have. And using experimental analysis, we can just keep these unnecessary campaigns from them. We can prevent this fatigue, this campaign fatigue from like happening to our different clients. And we can also design whole new campaigns based on the results of the successful campaigns, of the successful messages. If we already know that one group is very perceptive to, like, I don't know, like to rewards in their credit cards, well, we can make a campaign based on rewards using experimental analysis and unsupervised learning. And if we see that people, for example, in certain times of the year, they like to move out, like maybe we can give car loans, maybe we can give mortgages. So experimental analysis becomes very, very important in order to create new products, in order basically to bring a lot of the machine learning things that we are applying to the ground and to the clients directly. We can also create new products based on successful experiments. Perhaps a new credit card. Perhaps you can take your different clusters, and different clusters are going to have credit cards, and you have to know which credit card is the best for each cluster. And perhaps it's not a card that you already have. Perhaps it's going to be a whole new credit card that is going to come out of a successful experiment. But perhaps a new loan. Perhaps you don't care that your rate is going up year by year as long as it's low enough at the beginning, or the other way around. You want your rate to go lower and lower every year. So you don't care it's very high at the beginning. So you can have different loans. You can have different products. This is one of the panaceas for artificial intelligence, new products. And this is regardless the industry. It can be financial, it can be banking, it can be retail, it can be like coffee shops. Like creating new products should be like one of the things that we can do with artificial intelligence. And with a mix on supervised, unsupervised learning and experiment analysis, we can do this. Okay. So actually, as I told you, like actually I run short on time. I thought like there were going to be way more questions. Just to close, basically, to close the talk, the way we can mix machine learning model to give unique experiences to our users, it's basically this virtuous cycle. And it's something that it's very hard to implement in real businesses, okay? So for example, you can use classifiers to give the best product. Like you have a new client, right? You have a new client and you use a classifier. And with that classifier, you give like a loan, a credit card, whatever. Once she or he is a client, you can allocate the profile in order to offer new products. This is where use k-means. Here you use logistic regression, and here you use k-means. And then you allocate and you can offer new products like based on that new profile where there were. And then you can use experiment analysis and the new history that this client is creating in the bank to actually go for new clients outside, or just give again the best product. And you have like this very, very virtuous circle that help you basically, and it's fed using machine learning and using artificial intelligence, and helps you to basically have new products, new clients, and have the best possible experience for them. And basically what we have here is the promise of artificial intelligence in finance. Why? Because each of the clients is going to have their personalized experience that they want so much. And you're going to be able, because it's big data, because it's machine learning, to do this with millions of users in a single day. So you can give personalization to all of your users, all of it at the same time. So this can only be done using like machine learning and data science. Like this can't be done otherwise. Okay? This is basically the future of banking. It's also the future of many other industries. And here in this tutorial, basically, we saw how you can use logistic regression, k-means to do all of this. I didn't use data because obviously I can't use like real bank data for this. It's like just an insight of what's happening inside. And just like a quick view of what's coming in the future. Probably a lot of you are using reinforcement learning. I won't go in what reinforcement learning is, but basically a lot of businesses are trying to use reinforcement learning to create reward policy systems to help the clients with their decisions. It's like not so much as to drive them to do something, but once the client is in certain situation, maybe a loan going bad, maybe they're defaulting, well, which policy is the best one, right? In terms of like contact or like restructuring, those kind of things. And also using reinforcement learning, you can help businesses to know better the client's behavior. So we can know better whether our clients are going to default on a loan, whether they're not going to default on the loan. Like that's a very important application. And which kind of policies should be set in place in order for them not to default on a loan, not to wait until they're already 3 months late to do something. Try to be ahead of the curve. So this is the new trend in banking, reinforcement learning. Very few banks are doing it, like all around the world. And well, as I told you, I thought it was going to take longer. So I would like to take questions if you have questions right now. If no, I'll be around. You can follow me on Twitter, which is my Twitter. It's @ León Palafox. Okay. So if you have any questions or comments, I'm here.
Thanks, Leon. Thanks, Leon. I like to summarize some ideas before it finish. I consider very important the first ideas at the beginning of your tutorial. In particular, when you talk about that is no longer primary based on the money, but trying to help the clients to achieve the financial goals. I think that this is very important because, as you also say, the money, moreover, in the traditional concept of money, disappears. And now there is the new platform, digital platforms. So I think it's for me a new concept that banks, we traditionally think that bank is it's money, okay? But now you say that is very important the goals of the customers. Moreover, these new trends of banking, because I think that if bank continues with the traditional approach, they they must evolve, and this last idea of new trends you are presenting based on the profiles of the new clients and the life cycle. I think it's very important to know how the machine learning can improve in your processes, I think.
Yes, I agree with you.
There is a question from Facebook, Bernardo.
Let's see, Bernardo, it says for procurement application. What do you mean by procurement applications? Just like, give me a couple of examples, please. And while they're answering those examples, I would like to ask you if in your company it's common to implement machine learning algorithms on premise, of all the work is made on the cloud, or use a hybrid approach. Which language are you using for this process? So these changes from country to country. In Mexico, there's a lot of regulation on putting data, like sensitive data in the cloud. Actually, we have many restrictions around that. So, and this is like pretty much for all the banks and all the financial systems in Mexico. So it's sometimes we use a little bit of the cloud, but not that much. I would say like a hybrid, but mostly on site. And languages, R and Python mostly. I like Python, but R is like for experimental analysis, R is very, very good. And yeah, those two languages. There's because in banking there's still a lot of SaaS being used. So like if you want to get into finance, you probably also should learn a little bit of SAS, just to be sure. Then David Guzman asks, in my experience, what's the most important obstacle for a data scientist who want to transition from academy to industry? And my experience is actually to understand what industry needs. As like, for example, you wanna work in Nestle, for example, like they make products. Like I have a couple of students that they are working at Nestle. Well, you have to understand that accuracy is not everything. Like they might not be willing to wait 1 year for a new algorithm. That's what I was telling you. Like logistic regression is good enough. You don't have to have the best algorithm out there. You only have to have an algorithm that is better than the one of the competition. And like a good designed algorithm usually does that work. So in my experience, one of the biggest obstacles is to understand industry, to understand that the metrics in industry are different from the metrics in academy, that an algorithm has to solve a very particular industry-oriented problem. So like you have to be able to find the problem. And in academics, it's pretty much depends on the area of study that you are, obviously. But if you're very focused on computer science, perhaps the problem goes towards increasing the speed of reducing the complexity. And in companies, they don't really care about it. Like they care about different things. So trying to understand those little things about what moves industry and what are the incentives over there is one of the hardest parts of doing that transition. And my recommendation, if someone wants to do it, is get experience. Like if you're in a master's, if you're in a PhD, go and do internships in companies. They are like companies really right now are looking for data scientists, like a lot of them. So go and look for internships, go and ask people in LinkedIn, send like random messages and like, I'm doing a PhD on machine learning and I would like to get like some experience in the industry. Like maybe you can help me, that kind of thing. Then Nelly Hernandez, she asks, do you think it's a good turn from someone engineering to data analyst? I think software engineering to data analyst, it's good. I mean, you should probably put some care in ramping up like the machine learning part and the statistics parts and the math part. Like you should really put a lot of attention into that, because that's one side I see like from software engineers that actually they're very good in terms of programming, in terms of deploying systems, but when it comes to the actual modeling, they're lacking in some of those areas. So I would really recommend you to take like statistics courses, like machine learning classes. But I do things like it's very doable. Like you already have the programming, which is like halfway through. Do we have any more questions?
Not from YouTube. And not from YouTube. And I think the Facebook questions are also answered. And well, I think all of the participants are very thankful with you.
Cool. Well, I think is there no more questions? Thank you very much, Oscar.
Thank you to you, Leon. Thanks, because I think that for this kind of tutorial, of course, you are dealing with points, such sensitive points, as you say, race, and moreover about the same Banorte rules. I think you must to take care of not to talk about something controversial issues, I think.
Yeah, a little bit, but
Well, I think there is no more questions because the questions were along the session. Very good. It was very interactive. In other tutorials, the questions are in the final of the tutorial. But well, Iram, are you there? Is there some of the organizing committee who want to say something to Leon or to finish this tutorial? No? Well, again, on behalf of the Mexican Society for Artificial Intelligence, let me give me a few seconds. I will show your diploma. Give me just a few seconds.
okay.
I will show the diploma, and I need to use the screen to share my screen. Now it's online. The Mexican Society for Artificial Intelligence, SMIA, and the Universidad Panamericana award this certificate to León Palafox for giving the tutorial Machine Learning for Financial Applications at the 19th Mexican International Conference on Artificial Intelligence, MICAI 2020, in Mexico City, October 12 to 17. In the name of Felix Castro Espinosa, SMIA President, Lourdes Martinez Villaseñor, Program Chair, Oscar Herrera Alcántara, Program Chair, Amiram Ponce Espinosa, MICAI Local Chair. Thanks, León Palafox, an excellent tutorial.
Thank you, Oscar.
Hay muchas cosas divertidas y útiles que puedo hacer. Muy bien. Hay muchas cosas.
Sorry. Okay, thank you, Leon. We have finished this tutorial. An excellent tutorial. And there is no more. I will send you this certificate by email.
Okay, thank you.
Thank you. Thank you.